Wouldn't it be great being able to run code on demand without having to explicitly provision or manage infrastructure? And having more time to focus on what really matters. Programming awesome applications. Well, don't worry, because Microsoft's got you covered. Let's talk about a service known as Azure Functions, where we can build apps faster with a serverless architecture. We don't need to worry about provisioning and maintaining servers. We can easily build apps you need using simple serverless functions. We can use the programming language of our choice. We can scale on demand, pay only for the resources you consume.
Yeah, so it's a response to a number of things, but mainly it's around removing traditional barriers and building and deploying software to solve business needs. Traditional apps are designed to conform to the infrastructure they run on. Serverless apps offer an app-first model by abstracting away the infrastructure to relieve the developer from the operational complexity of running applications. The infrastructure only fires up when it needs to. It's serverless because you no longer have to worry about servers, virtual machines, patching, scaling, all those pieces that traditionally you have to manage and take time away from creating solutions. With serverless, you simply define your code or the steps that need to happen, publish it to Azure, and the rest is automatically taken care of for you.
Let's talk about managing apps instead of infrastructure. It is a fully managed compute platform with high reliability and security. With scale on demand, our code gets the compute resources it needs. So how does it optimize for business logic? Well, we only write code for what truly matters to our business. It provides a microservices-friendly approach for building more scalable and stable applications. We can utilize an innovative programming model for everything else, communicating with each other's services, building HTTP-based APIs, or orchestrating complex workflows.
Logic Apps is our Azure service for doing integration. And what do I mean by that? Well, it's everything from traditional workflow where you may have elements of user interaction where maybe you want to send data and wait for a response to come back over email or some other channel. But it's also things like business process orchestration and also things like data integration, which is what I'm going to talk about here. How do I get data out of one system, maybe do some work on it, traditional kind of EDL type workloads, as well as messaging type synchronization patterns. How do I implement that kind of stuff on top of Logic Apps? So Logic Apps comes with nearly 180 connectors now. Just a few kind of logos on the right-hand side, but the data-oriented ones sort of break down into a number of different categories. We have database connectors, things like SQL Server, both on-premises and in Azure. Then we have things like messaging. So how do I move to more of an event-driven type approach? We have a new Event Grid connector that we just shipped a few weeks ago. We also have Service Bus, Event Hub, and IBM MQ series as well. So if you have MQ and you want to use message-based integration between different systems, you can do that too. And then we have some data services in Azure, which you also have connectivity to. The primary ones are Power BI, if you want to push data to Power BI. We can also push data to Long Analytics, so Operations Management Suite. And we've also pushed data to Azure Data Lake as well. And then there's application kind of centric data integration. Things like Office 365, Dynamics 365, Salesforce.com. All different channels to get data in and out of your enterprise and your integration scenarios, both being able to trigger when something happens, when something changes in one of those applications or databases, and make something happen downstream and push that data to one or more other systems. And then there's this kind of lumpy data, so the bucket of other things, everything from OneDrive and Dropbox and Google Drive through to things like Azure Blob, Azure Storage Tables, and other artifacts. So a very rich set of connectivity.
We can develop our own way. We write code in an easy-to-use web-based interface, or we can build and debug locally on your machine with your favorite development tools such as Visual Studio, and also Visual Studio Code. It's got built-in continuous deployment. We can use integrated monitoring tools to troubleshoot issues. We can leverage the same functions code for multiple targets, Cloud Service, Azure Stack, or IoT Edge.
We'll go into the portal and click New, and then we'll look for Function Apps. Once we find that, we'll create a new one. And then we'll name the function app. We'll call it my new function. We'll keep all the defaults, but we'll also check pin to dashboard so we can easily find it once it's been created and deployed. Now once it's there, it'll appear on the dashboard. We can see it here in progress. And then once Azure's deployed it, it'll go right to that function app for us so we can begin creating the piece that we need. Great, it's been deployed. Now we can go into the function by clicking on functions over here and then click on new function inside there. So we have a function app that's going to have a function in it. We'll filter down by JavaScript because that's the language you want, and we'll select HTTP trigger. We'll give it a better name like heroes. And we'll make the authorization level be anonymous. And then we'll change the contents of the function in here to just simply return a list of heroes. So we'll do a little copy paste and we'll put in there a response of Mr. Hero, Miss Super, Kid Power, and status. We'll save it and run it. And then we can see the results right here in the portal. Well, that's not super helpful because we want to hit it from an external site. So we're going to click on Get Function URL. We'll copy that URL. And then we'll go over to Postman, which allows us to hit a URL from anywhere. And then we can click on Send, and we can see the results of our function right here.
So what else can you do with functions? A great example of serverless architecture can be seen through a web application backend. Let's talk about a real-life scenario with a queuing mechanism. Basically, our web application backend is hosting an API. When a HTTP request is made to that API, a message is then passed onto a queue. In this case, we will use a service bus queue. Once that message has been received on the queue, it will then trigger off another function. That function will then run a workflow to get the message off the queue and produce a record to be inserted into our Cosmos DB service. All this architecture has been completely hosted on serverless-based architecture with no infrastructure. Another great example could be a mobile application backend. A mobile app will make a HTTP request to a web API hosted on a function. When that serverless function is called over the API, it will create a purchase order and store the purchase order as a record in a Cosmos DB database. We can then set up another functions trigger attached to the Cosmos DB database service. Once that record has been inserted into the Cosmos DB service, it will then trigger another functions workflow that will create a push notification that will be sent out via Notification Hub. This example uses the concept chaining, where other functions are called from other functions. Another example of a serverless architecture can be around real-time file processing, where a PDF might be uploaded to a blob storage service. Once that blob storage service receives a new record or PDF file, it will then trigger a functions workflow that will then decompose the PDF file and send this decomposed file to a cognitive service. The cognitive service will handle OCR detection with the decomposed PDF file. Once the OCR process is completed from the cognitive service, this return data will then be passed to a new record and inserted into an SQL Server instance. Let's talk about another scenario where we might have real-time stream processing, where large amounts of telemetry data is collected from a massive scale cloud app, which is designed to ingest large amounts of data in real time. When Event Hub receives this telemetry data, it will then kick off a functions workflow, like the blob storage trigger we saw previously. The triggered function will then run a workflow for passing that data or process that data into a Cosmos DB service. We then use this Cosmos DB data for producing graphs or visualization. It could be through Power BI or some other graphing mechanism. We might even use functions to do an automated scheduled task. Ideally, we might have a repetitive task that requires cleansing of an SQL database, where we will remove duplicated records at a 15-minute time interval. This is using the power of timer-based functions, where we can set a certain time interval to run a specific workflow. Once the data has been cleansed, it will be passed back into another SQL database. Finally, we can save the best for last. Let's talk about extending SaaS-based applications. Let's say we have an issue that's logged into GitHub. You can actually attach a triggered webhook that will run a functions workflow every single time an issue on GitHub is submitted. We can even extend this integration into a Slack channel, so we can pass the details of an issue all the way down to a channel on Slack, giving full end-to-end automated integration from GitHub all the way through to a Slack channel.
Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs.
And that's all for today, guys. Thanks for watching. Please like, subscribe, and share this video for more tutorials.